Welcome back to For the Mariners by the Mariners channel. In the hazardous environment of a ship engine room, the boiler low water level alarm is the most critical safety device, standing between normal operation and a catastrophic dry firing of the pressure vessel. Ensuring this alarm triggers at exactly the right moment is a non-negotiable duty for every marine engineer, requiring a precise calibration procedure that tests both the mechanical and electronic response of the system. Before you begin any calibration work, you must inform the bridge and the duty engineer, as the process involves deliberate interference with the boiler's safety interlocks. Ensure the boiler is under steady load and that you have a clear view of both the local gauge glass and the remote control room display. The calibration typically involves the level transmitter or the magnetic float switch housing mounted on the side of the boiler shell. Start by identifying the normal working level and the low-level alarm set point, which is usually marked on the gauge glass frame or specified in the technical manual. To begin the physical test, you must isolate the level controller from the boiler by closing the steam and water balance valves. Carefully open the drain valve on the float chamber to slowly lower the water level inside the housing while the actual boiler water level remains safe. Watch the gauge glass on the side of the chamber or monitor the milliamp signal from the transmitter as the level falls. The moment the water reaches the designated low-level mark, the alarm must trigger on the main engine room console. If the alarm sounds too early or too late, you must adjust the zero and span settings on the transmitter or move the position of the magnetic reed switches. For electronic transmitters, this often involves using a handheld communicator or adjusting potentiometers to align the output signal with the physical water level. If the system uses a float with a mercury or micro switch, inspect the mechanical linkage for any signs of friction or salt deposits that could delay the trip. Once the low-level alarm is confirmed, you must continue the test to verify the low-level cutout, which is the final safety that shuts down the burner and closes the fuel oil quick-closing valves. This second stage of protection prevents the boiler tubes from overheating and melting when the water disappears. After the set points are verified and adjusted if necessary, close the drain valve and slowly open the water and steam balance valves to return the float chamber to service. Observe the level as it rises back to the normal operating position and ensure the alarms clear automatically. Perform a final check by cross-referencing the local gauge glass reading with the remote indicator to ensure there is no deviation in the signal. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.